Austin, can you begin with the word of prayer? Austin? Adam?
Let's pray. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir-Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdina siratal mustaqim. Siratal ladzina an'amta alaihim. Ghairil maghdubi alaihim waladdallin. Amin. Amin.
Thank you very much, Adam.
Welcome.
We shall continue from where we left the other day in our previous lesson on linear motion. So today we'll do the equations of linear motion, the vertical projection, the horizontal projection, free fall, and quite a good number of questions from that concept. So we begin, and this is where you need to be very keen, because it requires you to think. We'll begin from, of course, you now know the three equations of linear motion. By now, you should be able to, you should have known the three equations without referring. So maybe before we begin, try to write on your book the three equations of linear motion to test if you can remember, if you understood the concept of the three equations of linear motion. The first equation is the equation to V is equal to U plus AT. The other one is S is equals to UT plus RVT squared. And the third equation of linear motion is V squared is equals to U squared plus 2AS. But while dealing with the motion under gravity, the acceleration will change to G. So while you are doing this topic in during before you went home, you were in then some introductions were done that all freely falling bodies are attracted towards the center of the earth with uniform acceleration called the acceleration due to gravity. That is how A in these three equations of linear motion will be changing to G. So we'll begin with free fall, and we know G, whether in mathematics or physics, G is normally 10. G is normally 10. G is 10 meters per second squared. Why is the unit of G, which is acceleration due to gravity, 10 meters per second squared? You see that it is taking the SI unit of acceleration. So G will be 10 meter per second squared. Free fall. For free fall, it is important to know that when a body is falling down under the influence of gravity, its acceleration, which is A, is equal to the acceleration due to gravity. So in free fall, ukishikilia hiyo kalamu yako at a certain height, wakati bado huja drop, before dropping, the initial velocity here, the initial velocity before you drop that pen is 0. Wakati unaachilia inateremka chini na inafuata the lane of gravity, inaenda downwards. Those joining, kindly mute your microphones. So in free fall, we see that the body is moving, is falling downwards, and if it is falling downwards, it is under the influence of gravity, meaning acceleration for free fall will be equal to the gravity. So in other terms, or in short, we are saying for free fall, A, which is acceleration, is equal to plus G. Kwa sababu zote zinateremka chini. It will be the opposite for vertical projection. For vertical projection, when a body is projected upwards, its acceleration A is equal to deceleration. And we know deceleration is also retardation, and it is negative. So for vertical projection, acceleration will be equal to minus G, because it is moving, the body will be moving in the opposite direction. Sasa unashika mawe, for this case of vertical projection, jiwe itakuwa inaenda juu, which is against the gravity, and that is the reason why for vertical projection, acceleration will be equal to negative G. We'll do some questions to test. So before we do this question, let me share something here. A minute, please. So you now know the difference between free fall. We are dealing with motion under gravity, free fall, and vertical projection. For you to calculate questions under these concepts, you first must know the relationship between acceleration and gravity in free fall, and acceleration and gravity in vertical projection. I'm sharing a question here so that we do it together. So for free fall, I hope you can see something here on the screen. You see how when a body is dropped freely, the initial velocity is normally 0. We are making these 3 equations of free fall from the original equations of linear motion. What is changing for free fall? What is changing for free fall? We are replacing acceleration with G because we are dealing with the motion under gravity. So we have the influence of gravity. So for free fall, the first equation will be V is equals to U plus GT. The second one, the same equation, but we are replacing A with G. And the third equation will be replacing G, A with G. Let us consider this first question. A stone is released from the top of a cliff 180 meters high. Calculate the time it takes to hit the water. So from the question is suggesting that you can know if the question is of free fall or if the question is of vertical projection. So a stone is released from the top of, you can even sketch from the top of cliff, which is 180 meters high. Calculate the time. So we don't have the time. We don't have the time for this, the time taken by this stone to reach the surface of water. But we have the initial velocity. We said the initial velocity before it drops, the initial velocity is 0. So U will be 0. From the equation, we have 180 meters high. This 180 meters high is the same as displacement, but the displacement is vertical, which is also the height. So we have S, which is 180, but S can also be the height. So if we have U, which is equal to 0, we have U which is equal to 0. We also have if we have U which is equal to 0, we have S which is equal to 180. We have U which is equal to 0. We have S which is equal to 180. It means we can use the formula S is equal to UT plus half GT squared plus half GT squared. But we have S which is 180 is equals to U which is equal to 0 . Can you stop what you are doing? Can you stop what you are doing? So can we substitute the values with the formula S is equals to UT plus half GT squared? It will be equal to 180 is equals to 0 multiplied by time plus half multiplied by 10 multiplied by T squared. Can you type the answer you're getting? Yeah. Can you type the answer you're getting in the session, the chat session there? calculate the time it takes using the formula S is equals to UT plus half GT squared. We'll get T will be equal to T is equal to the stone will hit the water after how long? The stone will hit the water Are you getting that it will hit the water after 6 seconds? Austin Minor? Austin Minor?
Yes, I got 6 seconds.
6 seconds. Can you briefly take us through your working, how you got 6 seconds?
So I took S, which is the distance at as 180 meters.
Yes.
Is equal to the initial velocity is 0. So 0 times
Yes.
t is 0.
Yes.
Then we have a half gt squared, that is a half the acceleration, which is 10 meters per second squared.
Yes.
Times
Yes.
t. So a half of 10 is 5.
Yes.
So you have 180 is equals to 5t squared.
Yes.
Divide by 5, we have t squared is equals to 36.
Yes.
Square root of t square root of 36, t is equals to 6 seconds.
Yes. Can you make sure now that in your working, you have the formula, you have the working, and answer with the correct units? So if you're indicating that your answer T is 6, it means the answer is wrong because it has no unit. So the stone is the water after 6 seconds. Question number B, the velocity with which it is the water. Larry?
I got
2149. Yes.
60 meters per second.
Which formula are we considering in this case?
I used V squared is equals to U squared plus 2GS.
V squared is equals to U squared plus
2GS.
2GS.
Yes.
We don't have V squared. We don't have V squared. We have U, which is 0.
Yes.
Plus 2 multiplied by 10 multiplied by, what is our S?
180.
180. V squared will be equivalent to
3,600.
3,600.
Yes.
So when we find the square root, we get V, velocity will be equal to
60
what?
meters per second.
Yes, 60 meters per second. Someone who used another approach apart from V squared is equal to U squared plus 2GS. Trench. Trench. Trench is not ready. Emmanuel.
V is equals to U plus GT.
Yes, you can also use V is equals to U plus GT and substitute the values. When you have the formula, you can get the answer. When you have the formula, there is no way you can know the formula and and then you find it difficult to use the formula to get the answer. We go to another question. Let me share another question here. As I share, can you do this question? A body is dropped freely from the top of a tower 45 meters high. A body is dropped freely from the tower of 45 meter high. Calculate the time taken by the body to reach the ground. A body is dropped freely from the top of the tower 45 meters high. Calculate the time taken by the body to reach the ground. Before you try that question, is it a question of free fall or is it a question of vertical projection? Enos? Is it a question of free fall or is it a question of vertical projection? Enos?
Free fall.
Yes, it is a question of free fall. Calculate the time taken by the body to reach the ground. 3 marks. Meaning,
Time is 3 seconds.
yes?
3 seconds.
You are getting 3 seconds. Can you take us through your working? Briefly take us through your working. Explain.
I use the formula S is equals to UT plus a half GT squared.
S is equals to UT plus half GT squared.
Where S is 45 meters.
Yes.
Initial velocity is 0.
The initial velocity is 0, so it will change everything to be 0. 0 times t will be 0.
Yes. Then a half 10t squared. So we'll equate to get 5t squared is equals to 45. Yes. Then t squared is equals to 9. Then t is equals to 3 seconds.
Yes, t will be equal to 3 seconds. Now, if you have managed to get the time, it will be very easy for you to get the velocity with which it is the ground. Enos, can you still take us through, or can you guide us how we can get the velocity with which it hits the ground?
So you can use V is equals to U plus GT, where we don't know V, so U is 0.
We don't know V.
Yes. So and
we
U
know,
is 0.
We know the initial velocity U. Tumesema wakati bado huja drop hiyo kalamu, kama umeshikilia a certain height, before you drop U, which is the initial velocity, will be 0.
Yes. Then G will be 10 and the time will be 3 seconds. So
and the time will be
so V will be 30 meters per second.
V will be 30 meters per second.
Yes.
Thank you very much. Question number 3. Let me share question number 3. Meanwhile, as I share, I will also read that question number 3. A body is projected vertically with a velocity of 40 meters per second. You can make some brief notes from the question. You must not necessarily write the whole question. Make some brief notes. For example, a body projected vertically with a velocity of 40 meters per second from the ground. You now know what is 40. 40 ni nini? Is it U or is it V? A body projected vertically with a velocity of 40 meters per second from the ground comes to rest momentarily at the topmost position and returns to the ground. Calculate the maximum height reached by the body. A body projected, let me share. Allow me to share there. Here is the question. A body projected vertically with a velocity of 40 meters per second from the ground comes to rest momentarily at the topmost position and returns to the ground. Calculate the maximum height reached by the body. Calculate the maximum height reached by the body. Before you calculate, can you make some brief notes from the question? It will guide you to a certain formula. For instance, a body projected vertically with a velocity of 40 meters per second. So this 40 meters per second will be equivalent to the initial velocity. So u will be the same as 40 meters per second. There is a point where this body will come to rest momentarily. Uko juu, it will come to rest momentarily, meaning the final velocity will be equal to 0. We also have the maximum from the question. Calculate the maximum height reached. This height can be also be the same as displacement. So we don't know S. Then you put a question mark. And because we are dealing with motion under gravity, we'll have G to be 10. It has already suggested a formula, 2 possible formulas. It has already suggested 2 possible formulas. We have V, we have U, we have S, we have G. So since we have V, we have U, we have S, we have G, which formula can be the most appropriate? Which is the most appropriate formula to use? Makori? Makori.
S is equals to U squared over 2G.
S is equals to?
U squared over 2G.
Square
over
U
2G.
squared over
2G.
2G. What is the answer you're getting?
80 meters.
Yes?
80 meters.
80 meters. That is one of the approach. Any other approach? Any other approach is using S is equals to? S is also the same as H maximum. S is also the same as H maximum is equals to U squared over 2G. You can also use another formula apart from that. Apart from that, we have another formula, Masharia.
V squared is equals to U squared minus 2GS.
Yes, V squared is equals to U squared minus 2GH.
Yes. Yes.
Can you take us through your working?
Okay. So in v squared is equals to u squared minus 2gs. We say minus 2gs since this is vertical projection. It's going towards the opposite direction.
Very good. Because this is a vertical projection. Yes, continue.
Okay, so we take the initial velocity to be 40 meters per second. So we do 40 squared plus,
it will be 0 is equals to 40 squared.
Yes, 0 is equals to 40 squared plus
minus. Is it minus or plus? Yes.
Minus 2 times 10 times s.
Yes. When you substitute that
so we find that 40 squared will be 1,600 minus 20s. So we take the 1,600 to the other side of the final velocity, which will be minus 1,600. We divide it by minus 20s to find 80 meters.
Yes. So make sure in your working you have the formula, you have the working, and you have the answer with the correct units. The correct unit for this case will be meter. But since the question is not restricting us to give the answer in SI unit, you can also give the answer in centimeters. You can give the answer in centimeters if the question is not restricting us to give the answer in SI units. But learn to work with SI units. When we use S is equals to U squared over 2G, we already have U squared, which is 40 squared, over 2 multiplied by G, which is 10. Can you press your calculators and give me the answer? When you use the S is equals to S, which is equal to H maximum, which is equal to U squared over 2G. It will be 1600 over 20, which is the same as 80 meters. The second question is calculate the total time of light. Calculate the total time of light. Trevor, calculate the total time of light.
4 seconds.
We have the total time of light. Can you take us through your work?
I use the formula V is equals to U plus V is equals to U minus GT.
V is equals to U minus GT.
And since V is equals to 0,
since V is equals to 0,
we say 0 is equals to 40 minus 10 times T.
Yes.
And then
when you substitute, you get T will be equal to 4 seconds.
Yes.
Any other approach? So I see you have understood this. I want to give you another random question. I'll not tell you if it is vertical projection or free fall or whichever. I want you to give me the answer of this question. A particle, we asked the Form 4s in the predictor exam 2023. Can we try this? A particle starts from rest. A particle starts from rest and accelerates uniformly in a straight line. A particle starts from rest and accelerates uniformly in a straight line. After 4 seconds, it is 20 meters from the starting point. After 4 seconds, it is 20 meters from the starting point. Determine the acceleration of the particle. 3 marks. I repeat, a particle starts from rest and accelerates uniformly in a straight line. After 4 seconds, it is 20 meters from the starting point. Determine the acceleration of the particle. Determine the acceleration of the particle. I want to pick someone at random. Maybe someone has just huenda tu mtu ameingia na akaenda kucheza PS huko mbali. Mwangi from Tuavad. Mwangi. Mwangi. Krieger. Where's my friend Mwangi from Tuavad? Can you unmute your mic and read the question? Mwangi, are you with us? Okring Emmanuel from 2, Saiwen from 3, former member from 2, Dartmouth. Okring. Okring, can you give us the formula? Brandon. Brandon Machuka. Brandon. Chege. Chege. Proceed. You're not responding. 24, 26, 489. 26, 489.
I've gotten the answer as 10 meters per second squared.
You got the answer is 10 meters per second squared. Eh?
Yes.
Any other answer before? Any other answer before we do it? Emmanuel. Proceed.
Okay.
Emmanuel. Trevor.
I got 5 meters per second squared.
You got?
5 meters per second squared.
5 meters per second squared. Any other answer before we do it? Brandon, can you now respond? Can you respond?
5 meters per second squared.
5 meters per second squared.
Yes.
Austin?
I got 2.5 meters per second squared.
Can you briefly take us? Can you guide us how you got the answer 2.5 meters per second squared?
So from the question.
From the question, can you repeat the question? Can you repeat the question?
I did not read the question, but
let me repeat. Let me read the question.
Okay.
Before, don't unmute. A particle starts from rest. A particle starts from rest, meaning the initial velocity. Brandon, can you mute your microphone? Brandon and 26489 and 26489. Yes. A particle starts from rest, meaning the initial velocity is 0. I told you to, in this topic of linear motion, learn to be making some brief notes before you answer the question, because those brief notes will get you to a certain formula from the 3 equations of linear motion, and you must first understand the question. So a particle starts from rest, the initial velocity is u is equals to 0, and accelerates uniformly in a straight line. After 4 seconds, we have t, which is 4 seconds. It is 20 meters. We already have s, which is 20 meters from the starting point. Determine the acceleration of the particle. Kama ungekuwa candidates, this was a question we asked in the predictor last year, 2023. Kuna wengine tumepata 10, kuna wengine tumepata 5, kuna wengine wamepata 2.5. Now we want to determine the correct answer here. Now, can you follow as we discuss? Can you follow as we discuss? Then you realize where you went wrong. Minor, continue.
So u is equals to 0.
U is equals to 0.
I use the formula S is equals to ut.
S is equals to ut plus
a half 80 squared.
Plus half 80 squared. Unaona sasa hii si swali ya motion under gravity, ni swali tu yenye iko na acceleration kivyake. Then proceed.
So u equals 0, so u times t is equals to 0.
U times t is equals to 0.
We are left with
plus,
S is plus a half.
If u is equals to 0, the formula can also be S is equals to half 80 squared.
Yes.
Continue.
So time is 4 seconds.
The time is 4 seconds.
But you have t squared, that is 16.
We have t squared, which is 16.
So we have S is equals to a half 16a.
Yes. Can you now substitute? Watu wanaweza kuwa students wanaweza kuwa wengine wanaweza kuwa wamekosea kwa kuweka t ndio t squared. A haina squared, it is half 80 squared. T ndio iko na t squared. CA. Continue.
So 20 meters is S, it's the displacement.
20 meters is the displacement S.
So a half 16a is equals to 8a.
Half 16a is equals to 8a.
If you divide, you get a is equals to 2.5 meters per second squared.
When we divide, we get a is equals to 2.5 meters per second squared. There is a possibility that someone has written the answer is A is equals to 2.5 meters per second, which is wrong. The SI unit for acceleration is meter per second square. So make sure you. So Brandon, where's Brandon? Where's Brandon? Where's my good friend Brandon? I hope you have identified where you might have missed the point. Emmanuel, you want to say something? Manuel 26246. Are you okay? So we proceed. We proceed. That is, you gave the answer to be. So you must indicate the formula. Can you mark your working? You must indicate the formula, then working, then answer with the correct unit. If you don't indicate the answer, if you don't indicate the unit in your answer, you miss 1 mark. If you don't indicate the formula, for this case, you also miss another mark. You can end up getting 1 mark with the right answer. You can end up getting 1 mark with the right answer with no units. So in any calculation question, can you indicate the formula where possible? Also indicate the unit where possible. I see you have understood the concepts of vertical. See, you have understood the concept of vertical projection and free fall. We can now proceed to another concept. We are reminding ourselves remember we did this topic, linear motion, for more than 2 weeks, but in our revision it is becoming easier. We can finish it within 2 days. We are almost finishing linear motion. So your cooperation is highly, your cooperation and response is very important. I'm sharing something. We do this last question before we proceed. Question number 9. Question number 9. Question number 7, this one. Question number 7. Question number 7. A ball is thrown vertically upwards and returns to its starting point after 6 seconds. Calculate the maximum height reached. As always, begin by making some brief notes. We already have the time t is equals to 6 seconds. We have g is equals to 10 meters per second squared. We have u Question 7 should also have it is moving with an initial velocity of 30 meters per second. Calculate the maximum height, meaning we don't have the displacement. We go to horizontal display projection. Horizontal projection. Horizontal projection. It is the last part, the last part of this topic. Horizontal projection. So be very keen. Then I'll give you some questions after this part of horizontal projection. Let us follow through this. Examples of horizontal projections. Those are water jets from a pipe held horizontally. Of course, even if you throw a body, for example, a stone, haitaenda tu straight mpaka huko mwisho, lazima ianze kurudi chini polepole. So we have those examples of horizontal projection. A bullet fired from a gun held horizontally, haitaenda tu straight mpaka mwisho. We also have a motion of a ball when it rolls over a table. At some point, lazima iteremke chini. So can you consider this diagram? Can you consider this diagram? If you understand this diagram, if we are able to understand this diagram, it will be very easy for us to calculate any problems or any, we can solve problems involving this horizontal projection. And this horizontal projection have quite a good number of questions, variety of questions. Can we consider a vertical line? And this one, the y axis, we can call it the y axis, and indicate the arrow as shown on the diagram. Then another horizontal line on the x axis. Call that line R. Call this vertical line U. So before releasing or before firing a gun, lazima iko somewhere raised, alafu iende ni kama inaenda horizontally ikireduce polepole. So for this case, when we consider the vertical part, the initial velocity up here, the initial velocity in the y-axis will be 0, meaning the velocity towards the ground when we consider the vertical, the y-axis, we'll realize that the initial velocity hapa juu itakuwa 0, but the final velocity hapa itakuwa na value. But horizontally, when the body is moving horizontally, the initial velocity remains unchanged. That is why you, in the first point, huku juu, the initial velocity is still the same, hata hapa chini. So the initial velocity will remain unchanged throughout the flight. When we consider the other one, that was for the vertical. When we consider the y-axis, we can now see the part of the x-axis. For the x-axis, I'm bringing the screen. I'm sharing the screen. So for vertical displacement, we realize that in the y-axis, when we considered the maximum point before we release, for example, before we fire the gun, ilikuwa raised to some distance. So hapo juu ilikuwa the initial velocity when we are considering the vertical displacement. Vertical displacement ni ya y-axis. So tumeona penye u was 0, meaning wakati inateremka polepole, the final velocity will have a value which is not 0. Now, let us consider this formula from the equations of linear motion. S is equals to ut plus half at squared. But u kwa vertical displacement ilikuwa 0. U was 0. We are considering the vertical displacement and the horizontal displacement individually. So can you ignore the horizontal displacement for now, kwanza? Let us deal with the vertical displacement. Can you begin by sketching an arrow towards the ground? Use as a vertical displacement, then another horizontal arrow. That will we'll use that one to explain the horizontal displacement. So for vertical displacement, we notice that the initial velocity hapo juu before you fire the gun is 0, because it is going for vertical displacement, the arrow is going downwards, meaning it is under the influence of gravity, and A will be equal to G. For vertical displacement, A will be equal to G, and U will be equal to 0. Can we substitute U is equals to 0 and A is equals to G to the formula S is equals to UT plus half AT squared? What is our new formula? our new formula will be the same as NOS. We are substituting from the formula S is equals to UT plus half AT squared for vertical displacement. We said from the vertical displacement, U is 0 is equals to 0 and A is equals to G. NOS, what is our formula after substituting? U is equals to 0 and A is equals to G.
S is equals to half GT squared.
S is equals to half GT squared. So that is the first formula. Can you highlight that formula for vertical displacement in horizontal projection? Can you note that formula somewhere? Then we go to horizontal displacement, meaning we are considering the arrow on the x-axis. So na tulikuwa tumename that horizontal displacement R. Can you name that horizontal displacement R? R is the range of displacement. R for this case is the range of displacement. Then we still consider the formula S is equals to UT plus half AT squared. Can you write the formula S is equals to UT plus half AT squared? But S for horizontal displacement is the same as R. So you can, in the second equation, you can replace S with R. Therefore, our new equation will be R is equivalent to UT plus half AT squared. So acceleration will be in the horizontal direction, but acceleration is 0. Acceleration will be in the horizontal direction for this horizontal displacement, meaning A will be 0. A will be 0. Can we now substitute where we have A? Can you indicate 0? Can you substitute it with 0 and give me the equation, our new equation? Twenty-six to 5. 26 to 5.
S will be equal to UT.
S will be equal to UT, but we said you replace S with R. Therefore,
R will be equal to UT.
R will be equal to UT. So for vertical displacement in horizontal projection, U is equal to 0. when u will be equal to 0, it will give us the formula. When we substitute, it will give us the formula S will be equal to half gt squared, For horizontal displacement at time t, for example, A will be equal to 0. A will be equal to 0, meaning from the equation S equals to ut plus half at squared, we'll replace or we'll substitute A with 0, and it will give us the formula S is equals to ut. But we said the horizontal displacement is the same as the range of displacement. So R will be equal to ut. Now, can we now try several questions here? Question number 1. A ball, we'll apply the two formulas. A ball is thrown from the top of the cliff 20 meters with a horizontal velocity of 10 meters per second. Calculate the time taken by the ball to strike the ground. Calculate the time taken by the ball to calculate the time taken by the ball to strike the ground. A ball is thrown from the top of the cliff 20 meters with a horizontal velocity of 10 meters per second. Calculate the time taken by the ball to strike the ground. 3 marks. So in this case, we say the horizontal acceleration is 0 since the body maintains its initial horizontal velocity through the motion. Ndio maana hapa tumesema acceleration in horizontal direction is 0. Why is acceleration in the horizontal direction 0? The horizontal acceleration is 0 since the body maintains its initial horizontal velocity through the motion. What is the answer? A ball is thrown from the top of a cliff 20 meters with a horizontal velocity of 10 meters per second. Calculate the time taken by the ball to strike the ground. Which formula are we considering in the first case? Which form, Jonathan? Jonathan M?
I use the formula S is equals to a half GT squared.
Yes. S is equals to half GT squared.
Yes.
What is our S?
Displacement is 20 meters.
Displacement is 20 meters. Hii displacement ni horizontal ama vertical from the question?
Vertical.
Ni vertical. Ndio maana sasa tumetumia ile formula ya vertical displacement. S is equals to half GT squared. So from the question, if you understand the question, you will know the formula. Continue. So
my answer is
before the answer, we are substituting S is equals to half GT squared, and we have S to be 20, which is equal to half multiplied by 10 multiplied by T squared. We don't have T. So when you substitute that one, you are getting the time taken to be
2 seconds.
2 seconds. Sometimes, sometimes some of you forget to do the square root of t, and they give the answer to be 4 seconds. Brandon? Brandon?
Yes. I've gotten the
You have
answer as 2
something to
seconds.
you have an addition or
No.
now Brandon, don't unmute your microphone. Don't unmute. Can you try this second question? Continuation from the first one.
Yes.
Calculate the distance from the foot of the cliff to where the ball strikes the ground. Calculate the distance from the foot of the cliff to where the ball strikes the ground. Calculate the distance from the foot of the cliff to where the ball strikes the ground. In simple terms, the question requires us to calculate the what?
The range.
The range. Very good.
Yes.
How do you know that the question is requires us to calculate the range? How do you know that?
Or from the illustration you gave us earlier.
Yes.
Yeah, where you told us that the x-axis, we should represent it with r, which is the range.
Yes. So it is the same as the range of projection.
Yes.
The distance from the foot of the cliff to where the ball strikes the ground. Continue.
So the formula to find it is the range is equals to u times t.
U times t.
Yes.
Which is the same as?
U is 0.
U is 0. Is U 0? Is U 0?
U is not 0.
For horizontal velocity, U is the same everywhere. U is equal. So U is equals to U everywhere. So what is the initial velocity? The horizontal velocity? The horizontal velocity is 10. U is 0 when we are considering a vertical displacement. Sawa.
Yes.
But this one is horizontal. This one is horizontal displacement, meaning the horizontal velocity will be equal everywhere. So what will you consider in this case, in this second question? We consider U to be, is it U? Will we consider U as 0 as U or U as 10?
10.
Yes, we consider U as 10 multiplied by
2 seconds.
10 multiplied by 2 seconds, meaning the two questions, the range is 20 meters.
Yes.
Meaning, if you fail the first question, you are likely to fail the second question. But you can get the second question, the second question, you can get 1 mark in the second question if you indicate the formula, even if you fail. Question number 3, question C. The first one was question A, the second one was question B. The third one, C, is a continuation of the same question. They are correlated. Calculate the vertical velocity. Calculate the vertical velocity at the time it strikes the ground. Calculate the vertical velocity at the time it strikes the ground. Jonathan, someone else who was not participated today. There is someone. Calculate the vertical velocity at the time it strikes the ground. G is 10 meters per second squared. Meaning, kama tunaongelea vertical velocity, what will be our initial velocity? Kama tunaongelea vertical velocity, what will be our initial velocity? We are talking about vertical velocity. Now, what will be our initial velocity? Regan? Our initial velocity will be? Yes, our initial velocity will be 0. Which formula from the three equations of linear motion will we consider? Kwanza hatuna vertical velocity, tunaweka v question mark. Tuko na g ni 10. Tushapata initial velocity u is 0. Yes.
The third equation.
We are using the third equation.
Yes. V squared is equals to U squared plus 2GS.
Yes. When you substitute with the third equation, what is the answer? What is the answer?
20 meters per second.
Very good. That is very correct. Apart from, we have several approaches in linear motion. We can also use another formula apart from that. Gift.
Yes, you can use the first formula.
We can use the first formula, which is V is equals to U plus
G.
Yes,
U plus
GT.
GT.
Wow. U plus GT. We can get the same answer 20. We will get the same answer 20 meters.
Yes.
So we have 7 minutes left. We have 7 minutes left. We'll do more questions. We'll do more questions on this. We can do 2 other questions. Now, can we now try this? Can we try this? A body projected horizontally at an initial velocity of 120 meters per second from a cliff, 300 meters tall. A body projected horizontally at an initial velocity of 120 meters per second from a cliff, 300 meters tall. A body is projected horizontally at an initial velocity of 120 meters from a cliff, 300 meters tall. Calculate the time of light. That is question number 1. Calculate the time of light. Calculate the time of light. A body is projected horizontally at an initial velocity of 120 meters per second from a cliff 300 meters tall. Calculate the time of light. Jeremy?
2.5 seconds.
What is the formula you are? What is the formula? Can you begin from the formula, then you proceed?
Okay, I use the formula S is equals to UT,
Yes.
whereby I substituted S with 300 since the cliff is 300 meters tall. 300 is equals to U, the initial velocity, which is 120 meters per second squared. Then 120 times T. So I take the 300 to the other side, and I divide by 120, then I get 2.5 seconds.
Okay. Though we lost you at some point, well, I can see we still have other people, others who want to respond to that question. Number one, we have 26,269. 26,269. 26,269 has disappeared. 26,489. 26,489.
I have gotten 7.746 seconds.
Yes.
I've gotten 7.746 seconds.
Yes, that is the correct answer. Can you take us through as the rest of you to follow? The rest of you kindly follow.
I've used the formula.
Yes.
S is equals to UT plus
What
half
is
GT.
what is your name?
Edgar.
Oh, Edgar.
Yes.
Yes, continue. Edgar from Edgar. What is the other name?
Murithi.
Okay, continue.
Since U is 0,
yes,
we'll use the formula S is equals to half GT squared.
What is guiding you to say that U is 0? So that the rest can understand how you settle in this formula.
This is because when the object was
I can repeat the question so that you proceed. A body is projected horizontally at an initial velocity of 120 meters per second from a cliff 300 meters tall.
Yes, since this body is projected horizontally.
Yes.
That means that the vertical velocity is 0.
Yes, it means that the vertical velocity is 0.
Yes.
Yes.
And that is what that led me to say that S is equal to half GT squared.
Yes. Continue.
Since S is 300.
Yes.
We get that 300 is equals to half.
Yes.
Times 10, which is G.
Yes.
Times T squared. We'll get that T squared.
Yes.
Is equals to 60.
Yes.
And then the square root of 60 is 7.746 seconds.
Thank you very much. I saw Nathan Juguna. Here. Nathan Juguna, you want to say something? You want to add, or even if what you wanted to say has been said, you can just greet us.
I got the same answer as him. Yes, there is nothing to add.
Okay, thank you very much. The second question, B, calculate the range. Calculate the range. The range will be easy because you already have the time. The range will be very easy because you have the time. What is the range? What is the formula? 26,489.
The formula?
Yes.
Is R is equals to UT.
R is equals to UT.
Yes.
Then you substitute. The third
Yes.
one, the last one, the vertical velocity with which the vertical velocity which the body strikes the ground. 2 marks. The vertical velocity which the body strikes the ground.
For this one?
Yes.
For this one, you can use the first formula.
You can use the first formula. It is not tied to the first formula. It depends with the how someone approaches this question. Yes, proceed.
Where V
is equals to
U plus GT.
U plus GT.
Yeah.
But
now V
yes.
is equals to 0 plus
Yes.
times the time, and the time is 7.46.
So
Meaning
the final answer is
it'll be 77.46 meters per
yes,
second.
77.46 meters per second. You can also use the other formula, V squared is equals to U squared plus 2GS, and it will give you the same formula. Maybe before we end our lesson today, for future planning, which other topics would you like us to revise? Other topics briefly. The next 1 minute, then we end the lesson today. 26, 6, 25.
Magnetic effect on an electric current.
Magnetic effects. Dylan?
Fluid flow.
Kevin?
Fluid flow.
Fluid flow. Techno BG6. Maurice? Makori?
Fluid flow.
Fluid flow. Tobias? Tobias?
Effect.
Yes?
Magnetic effect.
Magnetic effect. Albert?
Refraction of light.
Yes?
Refraction of light.
Refraction of light. Let us believe that those are the topics, the topics that let me believe that is a sample of topics majority of you would like to us to do to revise on the same. Otherwise, in case of any other burning issue, you can respond through your parents and suggest the topics. They will give us the topics from the group. Otherwise, have a nice day. Can now leave the group and prepare for the next lesson in the next 26 minutes.